Good evening, everyone. I'm so pleased to welcome you to the Westland Library. Thank you for your patience in getting everyone seated, and thank you for attending tonight's program. Tonight, we are going to learn about the rare but awesome phenomenon known as the Aurora Borealis. Here to help us do that is Melissa Kaelin. Melissa works with space weather researchers at the University of Michigan to uncover the mysteries of the aurora. She is the founder of the group Michigan Aurora Chasers and author of the book Below the 45th Parallel. Stick around after the presentation if you are interested in purchasing the book. Thank you so much for attending, and I hope you enjoy, and please help me welcome Melissa Kaelin.
Thank you so much. Can everybody hear me okay? Can you hear me in the back? Awesome. Well, a huge thanks to the Westland Public Library for bringing me out today. I've been giving these talks around the state of Michigan and the region for a year now, and it's a ton of fun, so I always enjoy them, and really appreciate the libraries for putting on great programs like this, and thanks to all of you for coming out. I have a lot of slides tonight, so I might rush through some of them depending on what everyone's interests are. I kind of try to read the room a little bit, but I'll be happy to answer any questions for you. If not, as we go, definitely at the end. I'm listening to myself on this mic and I'm thinking, wow, I'm really loud. But that's probably a good thing. So the first thing I like to do at these talks is take a pulse. You know, the biggest question we get with the Northern Lights is, will they be out tonight? And that is a really good question, it turns out. So before I get started here, I'm gonna do one quick little thing, and I'm gonna pull up my doohickey, and I'm gonna pull up my favorite Aurora forecasting tool and look at the numbers. And it looks like this. You're gonna wanna remember these numbers though at the end of the presentation, because we're gonna check back and see what our chances are of seeing the aurora tonight. So this is not real time. This is just what this aurora forecasting model looks like. But I have it on my phone. Right now we have, let me refresh, 38.3 gigawatts of hemispheric power. Now, probably you don't know what that means, but by the end of my talk, hopefully you will. So remember that number, 38.3. All right, let's dive in. I'll talk a little bit about myself, but I also want to know a little bit about you. So I want to sort of read the room. All right, how many people here have seen the Northern Lights in your lifetime, at least once? Show of hands. All right, I'm looking around. I'm trying to see where the viewers are. Okay. All right, how many of you have caught the Aurora Borealis on camera? How many photographers do we have? Successful photographers? All right, a few. Now, how many of you have seen the Northern Lights, but you've never seen them in color? Okay, all right, we have a few people who know that the Northern Lights don't always appear in color. That sometimes throws people for a loop. And that'll help me kind of talk to you a little bit about what happens to create the Northern Lights and the science behind it. So this is me. I'm a writer by trade, also a bit of a social media guru. I founded the Michigan Aurora Chasers, which is now at I think over 97,000 members. We're coming up on our 3-year anniversary, and we're coming up on 100,000 Michigan Aurora Chasers. I moved to Michigan in 2018 after seeing my first Northern Lights up in the state of Minnesota, where I lived for 11 years. And I do work at the University of Michigan, the Department of Climate and Space, where I am actually a manager of marketing and communications, and I get to interview some of the world's leading scientists about the science of the Aurora Borealis and what creates it for my day job. I am on the phone pretty frequently with agencies like NOAA, NASA, and even ESA to talk about what we're doing in outer space. So I have a pretty cool day job too. A little bit more about me. I've seen the aurora in 4 states now. And in November, I will be going to Iceland with the University of Michigan Alumni Association as a staff guide to help people see the Northern Lights. All right, how to catch the Northern Lights. And feel free to, well, actually, we'll try to save some of the questions for the end, I think, so we can pass around a microphone. So if you save your questions for the end and wait for that mic to arrive to you, I think we'll be able to capture that better on camera. So what does it take to see the aurora? Well, many factors have to align to create the northern lights, not only on Earth, but also in outer space. So we need the right conditions in space. We need what's called solar activity. Aurora starts on the surface of the sun, believe it or not, in a process that sends us solar wind that creates the aurora or the northern lights. That solar wind has to be directed toward the Earth. It has to have good composition. It has to be fast, dense, and have a high BT and a low BZ. And the conditions can change instantly. And we'll come back to some of these numbers and terms so that I can help you understand them. But we also need the right conditions on Earth. So if you've ever gone out searching for the northern lights, you may have had a hard time, not because the northern lights weren't active that night, but because of other factors. One of the biggest things I tell people is that in order to see the aurora, you really need starry skies. If you look at this photo, you'll notice, if you can see really closely there, that there are actually stars in the background that you can see right through the aurora. That's because the aurora happens at extremely high altitudes, and it happens way above the clouds. So if you have clouds blocking your view of the stars or the moon or even satellites, you're probably not gonna see the aurora either. So one of the first things I do when I'm out looking for the northern lights is I look for a star. I think at this point, some of my friends probably think I'm a little crazy. I'll be driving around at night, in the middle of the night in the dark going, where's the star? Where's the star? I don't see a star. Give me one star, please. Once I see at least one star, I know that I have an opening in the clouds that gives me a little bit of hope, especially in Michigan, the Great Lakes state, where our Great Lakes give us a lot of lake effect weather. You also need dark skies, and in Westland, and anywhere in the Twin Cities metro, this is especially challenging because we live in the city, we like to have a lot of light. We like our street lights, our neon downtown lights, all kinds of lights, and that light pollution can make it really, really hard to see the aurora, which is happening at such high altitudes and actually coming to us from outer space where we need dark skies to see it better. The moon phase can also be an obstacle. If you're going out searching for the aurora under a full moon, this isn't true everywhere in the world, but at our latitude in Michigan, that can actually wash out the northern lights, which can sometimes be really subtle in color. So a full moon is not the best time to search for aurora. It is possible to see the northern lights during a full moon, but it's really, really rare. And most people, when they catch the northern lights when the moon is out, are catching it either before the moon rises for the night or after the moon sets. So you can also use those moonrise and moon set times to help you on your chase. There are other obstacles too. We saw last summer, there was a lot of aurora activity, but no one could catch it because of what? Think about last summer and wildfire smoke, yep. The wildfire smoke really blocked our view of the night sky. And obstacles like wildfire smoke, mist, fog, all of those things can be obstructions to viewing the aurora. The farther north you go, the better it is to see the northern lights as well. And then eyesight visibility is a factor. Believe it or not, sometimes the aurora are out there even though you can't see them. And if you hold up a camera, even your phone camera, and point it north and take one test shot, even if you're not seeing anything at all, you may suddenly catch aurora colors on camera. So it's not always visible to the naked eye. Here are some things to consider though when you're going out aurora chasing. So one thing is you want a great location. But if you think about some of the places you can go where it's dark at night and far away from the city, and maybe up in the Upper Peninsula, in the wild, You're also going to run into some other things like moose or bears or waves off the lake, or maybe in the Porcupine Mountains, a cliff that you could fall off of. So when you scout out a good location, I recommend that you go out during the daytime first to find a good safe spot where you know what to expect, and then go back at night to shoot the aurora with your camera. This is really good for lots of reasons. You can find out whether the place you want to photograph is flooded. You can find out where to park. You can find out if you're going to have cell phone service there. A lot of places where you can see the aurora, you'll be off the grid. And so once you get really excited and want to call your friends or text them, you might not have that kind of luck. So it's really good to scout out your viewing location before you go out in the dark to know what to expect. The other thing this can do is if you're a photographer, or even if you're taking a photo with your cell phone, you can look for really interesting things to photograph in the dark. Like, I've seen some people photograph sculptures at night, or just a really cool tree in the silhouette against the northern lights. If you go out in the dark, you may not necessarily know that that's there. So go out and scout out good locations before you chase. You can also use light pollution maps to find the darkest skies. You'll want to consider cloud cover. One of the biggest things I forget to do when I get excited about aurora is check the weather. It's really, really important, especially where we live. Remember that sunset, twilight, and moonrise can be key factors on your aurora chase. You're not going to see the aurora until after the sun goes below the horizon. And I've talked with a lot of experts in this field, and they would agree that you're not going to see aurora until astronomical twilight. So that's actually going to be a little bit after sunset. You're going to have to wait, especially if you want to see it register with your eyes. Twilight is also a really tricky thing, because here's the thing I love about twilight. It's a really, really beautiful green. What else is a beautiful green? The aurora. So sometimes first-time chasers will go out right before the sun sets and they think, oh, I'm seeing aurora during the day. But you know what? Twilight, which happens both in the morning and at night, is also a really, really beautiful color. You'll also want to consider that the forecasts are actually not that reliable. And this is why. We've only been trying to forecast aurora since somewhere around the 1960s. It's a relatively new science. Aurora is also known as space weather. When we talk about clouds and storms, we're talking about Earth weather. But when we're talking about solar wind and the sun's activity, that's called space weather. And space weather forecasting is an emerging science. So even when we look at the best forecast we have for aurora activity from our national forecasting agencies, some of it is a little bit of an educated guess, because they're trying to figure out what's going to happen between the sun and Earth, which is about 93 million miles apart. So the forecasts are not that reliable. You can also watch for patterns of the northern lights. Sometimes there will be a really big show and you'll hear all about it. Maybe you're checking Facebook in the Michigan Aurora Chasers Facebook group and everyone was seeing it. It's out, go outside, and you get outside and you missed it. Oh man. But if you know the patterns of the northern lights, then you'll know that sometimes when the aurora is really strong like that, it will come in waves. So you'll have about 20 to 30 minutes of really great activity, and then that will disappear and it will go into a lull. And about 30 to 60 minutes later, you'll have a bigger wave of really great activity, and then that will go into a lull. And then after that, there will be an even larger wave of aurora activity. So if you're patient and you watch the patterns of the northern lights, you can sometimes catch the show even if you think you missed it. Now, that brings me to my last point about things to consider, which is a trifecta of safety, sleep, and sanity. You may not realize this about the northern lights, but in order to see it, you have to be awake in the middle of the night. And believe it or not, humans are not nocturnal creatures. We like to sleep at night, most of us, not all of us. So in order to stay sane when you're sort of depriving yourself of sleep or staying up later than normal or getting up early in the morning, plan for your safety. Make sure you know where you're going to land after you stretch, your time of being awake for that long. Do you have a friend that lives nearby? Do you have safe lodging for the weekend? Are you close to home? Can you, van camp, or do you have a tent? Think about where you're going to sleep, but also think about how you're going to stay sane, because the aurora is really difficult to catch, especially in the middle latitudes, which is where we are. So my number one tip is, when you go out chasing, plan one other exciting thing to do on the way, so that if the aurora doesn't show up, you don't have to go home empty-handed, because it's really difficult to catch. So maybe you like to go up north and search for 45th parallel signs and take photos. You could do that. Maybe you love to go out and photograph the sunset and see waterfalls. Plan to see a really great waterfall. I don't care if it's been 6 months since you let yourself have a donut. Have a freaking donut and then enjoy the ride home, even if you get aced. All right, so let's take a look at how aurora are created. To understand what causes the aurora, you have to understand the sun and the solar activity on the surface of the sun that creates the solar wind. So we have lots of different things that can create solar activity. The sun is this fiery, hot, just ball of energy, and it has all this magnetic field activity going on, and it's exploding with solar flares and eruptions constantly. Any of these kind of things listed here can create a solar wind, which will then lead to the process that creates aurora. We could have, the solar plasma in the sun could create eruptions. We call them coronal mass ejections, when a solar flare launches off the surface of the sun and flies through space. That's called a CME. There are also filaments that explode. We can get glancing blows from some of this stuff as it points toward the Earth and flies through outer space. There's also an ever-present solar wind that's out there all the time. And when the right conditions align, that can give us aurora. So here's a little bit more about that. I think we're going to breeze right through this one because I'm moving a little bit slower than normal. But we can monitor the sun really closely because we have spacecraft that are actually learning about the sun, like the Parker Solar Probe and the Solar Orbiter. And then we can also monitor what's happening right outside of space, because we have some satellites right outside of space as well. Or right outside of Earth as well. But there's all this space in between where we have nothing. There are no satellites or spacecraft sort of in that wide space between Earth and the sun. So there's a lot of space where anything could happen. We're monitoring the sun and the Earth, but there's all that data that can change in between, and we could get a dreaded dud at any time. Even when they tell us there's something coming, it could change direction and totally miss us, and then we get nothing. So that brings me to what allows aurora to actually come into Earth's magnetic field and be strong enough to reach us down here in Michigan. And I'm going to set this down. Well, maybe I'll hold on to it and point with it. So there's something that in the Michigan Aurora Chasers group we talk about, and we call it that pesky BZ. Now, what is the BZ? That's a really good question. The BZ is actually, okay, let me back up for a second. It's like a magnet. It's oriented in different directions with a northward direction and a southward direction. So let's say we get some solar activity that's shooting off of the surface of the sun. First, we'll get a solar flare. Then that will create a CME, and that will send us solar wind. And that solar wind is actually going to have its own charge, like a magnetic charge, plus or minus. Think of a battery. When you put a battery into your remote control or something like that, you've got to line it up correctly so that the plus side is on the right side and the negative side is on the right side. Otherwise, you don't get an electric connection that gives you that power. So the solar wind has its own orientation. And then the Earth's magnetic field also has its own orientation of plus or minus. And in order for the solar wind to enter Earth's atmosphere, it has to get past our magnetic shield into our magnetic field, form that connection, and then flow into Earth's atmosphere through the North Pole and the South Pole. We get both the northern lights and the southern lights, known as the Aurora Australis, in addition to the Aurora Borealis. So basically, the BZ is this charge right here. We want the BZ to be negative all the time in order to get aurora in low latitudes. Because when the BZ when that charge in the solar wind is negative, that's gonna form a better connection with our magnetic field, and it's gonna create an open flow of energy into Earth's atmosphere. When BZ is positive, it's the gatekeeper. It's like that funnel closes up and nothing comes into our atmosphere. All of a sudden we get no aurora. So we can talk more about that later if I didn't explain it that clearly. But basically the BZ is the gatekeeper. It's gonna tell you whether or not you get a northern lights. It can change very quickly, and it can even jump back and forth wildly. And when it does that, that means it's not stable. And when it's unstable, that can actually cause a lot of really great aurora activity too, because instability in Earth's atmosphere creates northern lights. All right, so if you really want to get into the science a little bit deeper and figure out whether or not aurora is going to happen tonight or on any given night, you'll want to look at the data of the solar wind. And this is a chart that I use, and I can show you where to get it. It's from the Space Weather Prediction Center, which is our national forecasting agency for northern lights. And it shows you kind of the breakdown of some of the most important aspects of the solar wind. I'm going to go from the bottom to the top to tell you what we're looking at. So the first thing we see here at the bottom is temperature of the solar wind. Now, temperature is not really that important for aurora chasers because the temperature of the solar wind is usually going to be pretty hot, but that heat doesn't make a big difference for us. The next thing up you'll see in yellow is the speed of the solar wind. Now, with solar wind speed, we usually want to see at least 400 kilometers per second, which is all the way up here, or better yet, closer to 500 kilometers per second or higher, because the faster that solar wind speed is, that means the faster that impact is coming toward Earth, and the faster that aurora could filter into Earth's atmosphere and create northern lights. It could create a really vibrant dancing display with lots of movement if we get that high solar wind speed. But if that solar wind speed is low, we're not going to get much of anything. The next one up is density in orange. Now density, this number varies really, really broadly. You can see anything from like 0.1 up to 1, that's pretty normal. Sometimes it goes all the way up to like 16, 32. The higher the density, that usually means the more color we're going to get in the northern lights. Because if you think about, like a crisp autumn breeze that blows just across Westland, with lots of little particles of leaves inside, the denser that wind is with particles, the more you're going to get hit with, the more potential you have to create activity. It's the same with the solar wind. So the denser that solar wind is, the more particles are coming at Earth, which is going to filter into Earth's atmosphere. And what happens is those particles actually get charged up and then intersect with molecules of oxygen and nitrogen and helium. And those air molecules emit light. That's how we get the colors. So the higher the density, the better chances of color. The next one up is phi. Phi is not really something we use in aurora chasing, so I'm going to skip that one. And then on top, this is the most important. So we talked about BZ. That's really the gatekeeper that's going to tell you whether or not we're going to get aurora on any given night. BZ is here in red. It's that red line that's hovering right around 0. And we want it to be negative, remember? Because if it's positive, the gatekeeper has closed the gate, we're not going to see aurora. So BZ is not really looking that great on this chart because it's not negative. When it goes negative, it's not going very far negative. And we haven't seen any spikes of it going in either direction. It seems to be hovering right around 0. Now, the good thing about this chart, though, and this is not from tonight, it's from a past date, is that the BT is giving us some hope. Now, the BT is the white line, And when I first looked at this graph, I said, where is BT? It's not even on here. It's all the way up at the top, right around 10. BT is the potential of BZ to move in either direction. So if you're looking for a negative BZ and you have a BT of 10, that means at any given second, you could get either a positive BZ plus 10 or a negative BZ minus 10. At any given second, it could be up 10, down 10. And 10 is a pretty big number when it comes to BZ. So when I'm looking at this chart and I'm seeing, that red line, that pesky BZ, that gatekeeper, it's not really cooperating, but the potential of BZ to drop at any second is all the way up at 10, and that could happen instantly. I know that I'm gonna watch this chart and see if anything changes and keep my eyes open for northern lights. Because the instant that BZ drops down, the gates are open and in comes the aurora. All right, so next up we have, and I have some more slides on this, so maybe we'll go through it fast, the K index and the G storm scales. So when we talk about aurora activity, it's created by geomagnetic activity. Those aren't the same thing, but they're very strongly correlated. And they also have geomagnetic storms. So you can think about thunderstorms, tornadoes. Sometimes when you see a watch for those, you know that the conditions are present that could create that type of weather. When you see a warning for a tornado, you know that a tornado has touched down on the ground and it's actually happening. So our National Forecasting Agency will issue warnings and watches for geomagnetic storms. When there's a watch for a geomagnetic storm, the conditions are present that could create northern lights. Now, when there's a warning for a geomagnetic storm, that means it's happening, there's really strong potential for aurora right outside our atmosphere, and it's headed right toward us. So I actually subscribe to alerts for watches and warnings, and I get these right in my email. And I know when a storm is headed our way because I get the warnings, which is really cool. But the K index is a scale of 0 to 9 that is going to tell you the strength of the aurora. So 0 means no strength at all. They can't even see aurora in Alaska or Canada. And 9 means this is going to be the most epic aurora display of your life. It could be seen all the way to Texas, Oklahoma, Nebraska, Cuba, in the most historic show of all time. So the K index is a scale of 0 to 9, 0 being the lowest, 9 being the highest. Anything below a 5 is below storm levels. And we can't really get too excited about that because it's not going to bring us much aurora in Michigan. Now, once we hit K5, that is equivalent, or KP5 as you see it here, that's equivalent to a G1 storm or a minor storm, a minor geomagnetic storm. Now, a G1 is going to affect our power systems. We're going to have weak power grid fluctuations, believe it or not. It's going to have a minor impact on satellite operations, and it even affects migratory birds at high levels. But at the bottom of the scale, you'll also see aurora is often visible at high latitudes, including Michigan and Maine. So G1 storm means we could see aurora in northern Michigan. At a G2 storm, a moderate geomagnetic storm, which is equivalent to a KP6 or a K6, we can actually see aurora across the entire state. So what do you need to see aurora right here in Westland? Well, you need dark skies for one thing, but you also need a K6 or a KP6. At that level, aurora can be seen anywhere in Michigan as long as your skies are clear and dark enough. A G3 is going to reach all the way down to Illinois and Oregon. A G4 is going to reach all the way down to Alabama and Northern California. And a G5, as they state here, aurora has been seen as low as Florida and southern Texas. So that's your scale. So we're talking about the K index. And I'm saying K, and then I'm saying KP. And this is the number you're going to see in any aurora forecasting app you use, right? Who here uses an aurora forecasting app? Anybody? So you're getting the K, or the KP. What's the difference? Well, the K index is actually measured at different spots around the globe by magnetometers. And when it's K, that's just one measurement that's telling you exactly what's happening in terms of the strength of the aurora. So if we have K5 in Boulder, Colorado, that means the aurora is at a strength of 5 in Boulder, Colorado, which is pretty straightforward. The problem is when we use KP, the P stands for planetary average. So KP is a planetary average of aurora strength that is measured from magnetometers across the globe. So now we're talking about measurements of the aurora strength that were taken in Boulder, Colorado, as well as Sweden, as well as Canada, as well as Alaska, and they take the last 3 hours and they average those together, and then you get the KP. It's a 3-hour average of what has happened in the past. Now, the National Forecasting Agency, the Space Weather Prediction Center, uses the KP to issue the forecast, so it will give you what's going to happen in terms of a 3-hour average. But when you're actually chasing the northern lights, you want to be really careful. You could get an alert on your phone that says, KP6, get outside. The aurora can be seen anywhere in Michigan. Well, if that were a K6, that would be true. But at KP6, that's a 3-hour average. It could be a 3-hour average from the past, and your alert could be telling you aurora was just high enough to reach all of Michigan, and you missed it. So just be aware that that is a 3-hour average, and it can be very misleading. So what do I do when I want to know what's actually happening with the northern lights? Well, this is where we started with the ovation model. The ovation model are measurements taken at the L1 point from a satellite just outside of Earth's atmosphere in outer space. So this aurora forecast is actually a detection of the actual energy from the solar wind that they are measuring in outer space right now. This isn't tonight's, even though red on the map is really good and that looks amazing. But when we use the ovation model, we're looking at real data about real activity. All it has to do is have a favorable BZ, that gatekeeper, that open flow of energy, and then suddenly we get northern lights. So this is how to read the ovation model. It's really simple. Up in the top left corner, it just has the NOAA Space Weather Prediction Center, so the title, with the aurora forecast. And then these numbers look really confusing, but it's actually just the date with 2022 first, and then this is from Labor Day, so September 4th, then the time given in the format of military time and universal time. So you're looking at the year, month, date, and the time. So this is just the aurora forecast for this date and time. In the opposite corner at the bottom right, it just says this is the ovation aurora model. This is the model run time, so this is what time they did a run of the model with, again, the year, month, date, and time, and universal time. And then these were the observations taken at the L1 point, and that was the time that those were taken. So basically, you're looking at timestamps. Now, the important part is this chart here, the probability of aurora, is going to tell you on a scale of 0 to more than 4, or a probability of 0 to 100%, what your chances of seeing the aurora are. The more red and yellow and orange you have on the map, the better your chances. So you can kind of use these colors to guide your eye. Do you think that the aurora looks good on this map? Yeah, absolutely it does. This is almost as good as it gets. Well, not quite, actually. It goes quite a bit higher. Now, the kicker here is that you can actually look at how many gigawatts of hemispheric power we are getting in the aurora. So we talked about the K. The K index is one way to measure aurora activity. Another way is hemispheric power. So this top right corner is the important part. This is going to give you a forecast lead time. It's going to tell you in 42 minutes what we see from this satellite will reach Earth. So you have a lead time of 42 minutes. And then it says the HPI is 104.3 gigawatts on a range of 5 to 200. And actually the scale goes higher than 200, I've seen it. But that hemispheric power, or that HPI, is your hemispheric power index. So basically, you can look at this hemispheric power or that index any time of night and refresh it and see, is it going up? Is it going down? Is it staying about the same? Has it been 5 gigawatts all night? Like, who wants 5 gigawatts? I think about Back to the Future, you know, when they're trying to time travel. They needs more gigawatts. Come on, you know, fire it up. So the higher the better. You can use this model to refresh it in real time and see if Aurora is getting better or quieter, or if it's staying about the same, or if it's kind of jumping in waves. And I'll give you the website for this. Actually, I have a really short link to it, and that's on my website because it's a really long URL. It's like services.swpc.northernhemisphere.gov/aurora/northern lights/ it's all these things. But if you go to kaelinart.com/aurora, I have this link right at the top. Now, I have to caution you with the Ovation model because everybody loves it and everybody is using it. And that's great, but there are several versions. There's a video version. When you play the video version, you're gonna see maybe about 30 seconds of activity, and you might see stuff like this and go, wow, it's really gonna be good tonight. Most of this video is of the past 24 hours, and then the very last few seconds are what's actually predicted to happen. So be careful if you watch the video version because most of it refers to the past. There's also on the Space Weather Prediction Agency homepage, there is the forecast version. Now they only started doing this within the last year or so, and this map, I'm sorry, but it never looks like that at like a K5. I don't know. A lot of us agree that it's a little bit exaggerated. People see all that red on the map and they go crazy. So when you see that Aurora forecast map on, you know, the mainstream news or your forecasting app or, you know, the homepage of the SWPC, take it with a grain of salt because it seems to overpredict. Now, the real-time model, the one that I just showed you, that has a very specific website that's hard to find, like I just said, but I'll share it with you. That's the one that is actually measuring activity right outside our atmosphere, giving us the lead time of when it's coming to Earth. So that's the one you want. So I've been chasing Aurora for 11 years now, and last year I celebrated by going to Alaska. Highly recommend it. I thought we're all Aurora enthusiasts here. Why not share some Aurora photos? And maybe some of you want to photograph the Northern Lights. Well, I only take photos of the Northern Lights on my iPhone 14. Most modern cameras can actually take really great photos of the Northern Lights. All you have to do is get a tripod or get your phone to hold perfectly still so you can get a 30-second exposure and put it on night mode. That generally gets you there. But for anyone who's interested, here are some basics to get you set up with Aurora photography. You definitely need a tripod. If you don't have one, all of your Northern Lights photos are gonna come out blurry. Most people like to use a remote. That way when you click that camera shutter, you're not shaking the camera at all. Extra batteries. You might be out in the cold and those batteries run out of energy, run out of juice real fast. Then, you know, if you're looking for what kind of lens to get, don't think about how big of a zoom you need, that kind of thing. You're not going to want to zoom in at all because actually you're going to want to be able to capture as much of the sky as possible. So just any wide angle lens, the wider the better, will do. And any modern digital camera is going to have great possibilities here. And I'm sorry we ran off the edge. But smartphones within the last 2 or 3 years are also going to be really good. So what camera settings do you use? Well, in order to master the Northern Lights, you're going to want to, when it comes to photographing them, you're going to want to kind of learn the exposure triangle and get used to adjusting your aperture, your shutter speed, and your ISO in the right proportions. The thing is, we could give you camera settings for Northern Lights and tell you this is going to work all year, but that would be wrong because some aurora are really subtle, some aurora are really bright, some aurora just explode in colors all around you. And you're gonna have to adjust your camera settings depending on how bright the light is that night. So the settings will vary depending on the display and your gear, but a lot of photographers like to set their focus on infinity. You have to get used to using manual mode. Don't use a flash, turn that off. And then here's some starting camera settings. Start with these and then adjust throughout the night. And you'll learn as you go, but depending on what kind of show you get, that will get you some great photographs. A shutter speed of 1 to 30 seconds is usually good. Aperture of f1.2 to f2.8, and a lot of people recommend an ISO from 800 to 6400. All right, I don't know how we're doing on time, but here's some photographs chasing the Aurora in Michigan. I actually was able to catch the Aurora east of Lansing on February 26th, so that's pretty close to here. And within less than an hour drive, I think on March 23rd of this year, I caught the Aurora just north of Flint. So the Aurora does come all the way down in Michigan, but those were during G3 storms and G4 storms, which are some of the strongest. But good news, folks, it is now January of 2024. And I have the pleasure of welcoming you to Solar Maximum. That January is the official beginning of Solar Maximum, which is a maximum in the 11-year cycle of the sun and the solar activity. It means that we could see more powerful and more frequent northern lights from now until October. So it's a really great time to start chasing. If you want to chase, use your maps. Map out your chase. Part 1, what do you need on the K-index? Well, if anyone can stay awake, I just told you, all of Michigan needs a KP6 or a K6. At K6, you would see them overhead through the middle of Michigan and possibly overhead here, and then low on the horizon a little bit farther than that. At K7, you're going to see Aurora definitely overhead on the Michigan-Ohio border, and you'll see it low on the horizon from points farther south. You can see the farther south you go, the higher you need that KP to be, the higher Aurora strength you need to see the Aurora, or to see the northern lights. So map out the chase part 1. Know what you need on the KP index. Mapping out the chase part 2. What is your parallel? Does anyone know what parallel you're at here? So we're north of 42 degrees, so north of the 42nd parallel. And actually the 45th parallel, if you're ever going up north, that's right across Traverse City and Grayling and Alpena, about that area. That 45th parallel is really when we start to think of, well, this is a big debate in Michigan, but that's where we start to think of the northern lifestyle. We start to see the boreal forest, we start to see more snow, we start to see some different types of vegetation from the north once you get up to the 45th parallel. So that's sort of a magic line where you only need a K5, KP5, or a G1 storm to see Aurora overhead. Now we could see a G2 storm overhead in this area, at the 42nd to 43rd parallel. So knowing what parallel you live near can help you figure out how strong of a KP you need or how strong you need to see northern lights. Mapping out the chase part 3, light pollution. This is a big one right here in Westland, and for anyone who lives in the Detroit metro area or in large cities everywhere. This is a map of Michigan on a dark sky map or light pollution map. This is Chicago. It's enormous. Anyone know what that is? Detroit, yep. And we are right outside of Detroit. In fact, Westland is right here. So we're not in the middle of it, but we've got a lot of red on the map. Now, once you start looking closely at light pollution maps, though, you can go outside of those red areas a little bit and figure out where it gets a little bit orange, where it gets a little bit yellow. A lot of folks will tell you you can't see northern lights from that type of light pollution. But I used to live just outside of Minneapolis. I've done it. So if you study your maps and figure out where your Bordeaux skies ratings are better, the Bordeaux scale is a rating of dark skies. How dark are your skies? And it goes from 1, excellent dark skies, to 9, which is the inner city. We're at a 7. But if you figure out where the skies get a little bit better, like a 6 or a 5, you may actually have a little bit of luck. So to work around light pollution deserts, as we call them, you really have to use dark sky maps and light pollution maps carefully, and I would encourage you to zoom in on them and kind of explore the neighborhood. So I took a couple more screenshots for you guys tonight of what it looks like around Westland. Let's see, I'm not sure where we are in this map. There we are, yep, right down there. I knew I did this for Westland. So yeah, Westland is here on this map. If you zoom in super, super close though, you can see that once you get out to Green Oak and Northfield and Hamburg, you start to get a little bit out of that light pollution. If you could go a little bit farther than that, you get a different Bortle scale rating. But you'll still have red to your north. You don't want that. You don't want light pollution to your north. So you can kind of use these maps to judge where to go. Now on this side, I've got Detroit on the bottom and the land directly north of us at the top. A lot of folks from the Twin Cities are going up to Port Austin to see the Northern Lights. There's some really great beaches out there. It's been a really safe area for people to go. And you can also see there's all this land where there's not quite as much light pollution. If you can find some parks or public boat launches or things like that, you might have a little bit better luck. This is the Aurora forecast. How we doing on time? I think we're okay. All right, so whoops, let me go back. So you can use the Aurora forecast to try to see when it's good to see Aurora. But in order to do that, you have to know how to read it. Good news for all you guys, I've simplified it. I've done the entire thing in a video on YouTube. So if you follow me on YouTube at Melissa the Aurora Chaser, you can watch a video that walks you through the whole thing very carefully. But essentially, let's break it down. The Space Weather Prediction Center, or the SWPC, issues the Aurora forecast daily. In fact, twice daily. They change them. They're always given in universal time. An example of that is 0000 hours to 0300 hours. Now that looks like a military time format. The kicker is you also have to convert that though, because that's not the Eastern time zone. So universal time, read it as military time, and then convert it for your time zone. Right now, we would subtract 5 hours to get Eastern time. Then you're given the expected KP. Again, we talked about KP, it's a planetary average, so you have to take it with a grain of salt, and it'll be given in 3-hour periods of universal time. So here on the Aurora forecast from May 11th of 2023, you'll see 0000 hours to 0300 hours universal time. So that's a 3-hour period. The expected KP on May 11th will be 3, KP 3. And then 0300 to 600, KP 3, 0600 to 0900, KP 2.33. They started doing fractions last year, and it really kind of drives me crazy because I've never done it before. And now anytime they have a fraction that is almost higher, they round up. So a K5 would be a G1 storm. They're rounding this KP 4.67 up to 5 to give you a G1 storm. Now, when I see that, I worry because I've been watching these, and those 4.6s, those 5.6s, they're really not making it down to Michigan Aurora Chasers. So I would wait for them to hit that number on the spot to anticipate a geomagnetic storm. Anyway, so we're looking at universal time, 3-hour increments. They're all lined up on the side here. That's your 24-hour day for May 11th, May 12th, and May 13th. And then you're given the KP in fractions with your geomagnetic storm equivalents. Remember, it's a forecast, and it's one of the hardest forecasts for anyone in the world to predict. In fact, at the University of Michigan, I work with researchers who are trying to figure out new satellites and missions they can launch to space to better understand the aurora every single day. So it's an emerging science. So when you read this weather forecast, don't take it as fact. Take it with a grain of salt. Anything could happen between the sun and Earth when we see this solar wind. And then understand the rationale as well. If you ever subscribe to the forecast, which you can do for free on the national agency's website. And on my YouTube, I show you how to subscribe. There's a video. So if you ever sign up for these, there will always be a rationale at the bottom. Understanding the rationale can go a long way to helping you become a good Aurora chaser. But it's really scientific in nature. So there's going to be some terms that you may not understand, and there's going to be some things that you might have to learn as you go. And we all start somewhere. I had to learn this from the ground up too. But the rationale for this forecast, which was telling us that we were going to get a G3 storm, a chance of a G1 storm, a chance of a G2 storm, some of the strongest storms were in this forecast. And the rationale was the arrival of the anticipated CME later on the 11th of May or 12th of May will likely lead to G1 to G3 storms, which is minor to strong geomagnetic storms. Unsettled to active levels of aurora activity are expected on the 13th of May as the CME influences wane. So again, a CME is a coronal mass ejection. That's what happens when that solar flare ejects from the sun, sending us the mass from the corona. So a solar flare itself will not give us northern lights. If you're watching your apps, a good one is Space Weather Live, but when you see that solar flare, you have to wait because some of those solar flares can be sucked right back into the sun. It's so powerful and it's so magnetic. A solar flare has to actually create a coronal mass ejection and spit that towards the Earth for us to get any chance of lights. And so the rationale for this really great forecast was the CME. All right, you're all welcome to join the Michigan Aurora Chasers. If you're not in it already, who's in the group? Anyone in the Michigan Aurora? Woo! Go Michigan Aurora Chasers. We have a lot of fun. We have some really great members. We always welcome questions, and we catch some really great photographs. The best thing about it is our members are posting live sightings of the aurora as soon as they're out, and they're trying to include as much detail as possible. Now, what's this guy, this stripe thing up here? Anyone know? Steve. So once you get into aurora chasing, it's actually a lot of fun because there's more than one type of aurora. Steve, which stands for the, let's see if I can get it right, the Strong Thermal Emission Velocity Enhancement. It's an acronym. Actually, Steve was created first, so it's a backronym. Steve is a sub-auroral arc that is similar to the aurora, but different than the aurora, and it appears with these green stripes, this picket fence, and you can actually see it even farther south in the night sky. So there's all kinds of aurora that you can catch out there. These are just some of our photos. You're welcome to join us. We do live chases when we can, and we take you out at night to see the northern lights. We're also on Instagram now at MI Aurora Chasers. We have a public-facing Facebook page and a Facebook group. And then we've got this link tree. There's all kinds of good stuff on it, including the ovation model, the real one, the live link. So that's linktree/My Aurora Chasers. It's a little bit tricky. You have to put the period right between the R and the E. Those are some of our websites. We're almost done here. Obviously, I've written a book to help you find the northern lights. Below the 45th Parallel, The Beginner's Guide to Chasing the Aurora in the Great Lakes region. I have copies here tonight if anyone would like to buy one, and I'm happy to sign yours. I'm on YouTube. As I've mentioned, I've been having a little bit of fun with that, although I've got a lot of ideas and I need more time to put them up there. And we have a lot of great upcoming events, including I will be speaking for the first time in the Night Photos Summit, which is virtual, February 2nd through 4th. I've got another library event coming up. Then we're going to do our second annual Michigan Aurora Chasers workshop, a whole day of learning about aurora forecasting and photography. And the Upper Peninsula Dark Sky Festival will be happening for the second time this year. I'm also one of the co-founders of the annual Aurora Summit, which is an international gathering. It's a weekend long. We celebrate the art, culture, science, and photography of the aurora, and we bring in a keynote speaker, an entire weekend of festivities, trivia, prizes. It's held in Wisconsin this year in October at theaurorasummit.com, and everyone's welcome to come. So lots of great opportunities for anyone who wants to get more involved. Now, that brings me to the end of my talk just about, but we have something to do here. Does anyone remember what the gigawatts were last time we checked? 38.3, close. And it's now 37.7, which means it's going down. But let me tell you what, this is on my phone. I usually have the brightness down because I'm a night sky enthusiast. This is the direct link from that forecasting model. Let me tell you what, 38.8 is actually, that's a number I get a little excited for. I don't know how clear the skies are in Michigan tonight, but I would say above 30 gigawatts of hemispheric power, you can actually see aurora low on the horizon from northern Michigan. And once it gets that strong, I start watching for it to get stronger and to push farther south. So if that number goes up to 60 gigawatts tonight, it may not. 60 is a little high, but I would go outside, especially if you live in a dark area. Maybe you don't. But those numbers are pretty good. And if anyone wants a road trip tonight, might be an interesting night to do. It's not a guaranteed night for sure, but those are really interesting numbers. So those are the best numbers I've had since I started doing this talk. So I have a few more links I'll put up here for you, and I'm happy to take questions. Again, if you could wait for the microphone to come around. But that concludes my presentation, and thank you all so much for coming. I've got a question right up here in the front. I don't know if we're passing out the mic yet.
When you talk about the ejections, that's okay. Can everybody hear me? When you talk about the CMEs, the ejections from the sun, what is that? Is that gases?
So the question is, when I talk about the ejections from the sun and the CMEs, what is that? Is that gases? Yeah, essentially, the sun is gaseous, right? But it also has this thick solar plasma, all these particles, and we're still studying the sun and learning so much about it. But essentially, it's a fiery, gaseous launch of dense particles through space that are coming toward Earth's magnetic field. Yep. And say that's accurate. Another question? One over here. And I've got some links up here for you too, and I'll switch to more in a minute.
I'm curious, is this working?
It's for the cable channel.
I'll repeat it. I think it's working for the it's working for the cameras. It's just not working for us.
I'm just curious. You said you went to Alaska and saw them. I have an upcoming trip in March, and I wondered where you recommend going to. And
Sure. The question is, she has an upcoming trip to Alaska in March, and where would I recommend going now that I've been? When I was there, I was thinking, man, why didn't I visit Anchorage? That would have been so beautiful. It was my first time in Alaska, and that's right on the ocean. I went to Fairbanks, north of the city, just outside the city, and stayed at an Airbnb. And I'm glad I did that, because I think what you want to do is you want to avoid the oceans. Anytime you're next to a huge body of water like that, it can create a lot of mist and weather and fog, and all those things are going to prevent you from seeing the aurora. We even went in the middle of the night to a beautiful lake in the kind of the flat areas near Fairbanks, and so much fog was rolling over it at night that we couldn't see the aurora there. We had to move. We also, though, I traveled with a group, and we had a real experienced tour guide, and we also drove all the way up to Coldfoot, Alaska in the Arctic Circle and saw it from the mountains. So if you're on the right side of the mountains, and I don't know enough about Alaska to tell you which is the right side, or in the plains or somewhere far away from bodies of water, you're probably going to have better luck.
well, I'm flying into Fairbanks and then to Bettles, which is in the Arctic
Circle. That should be good. So. That should be good. But you may have to drive out of the clouds. And even in Alaska, especially if you're near a city or right in Fairbanks, you might still see some of those light pollution effects. You might still have to let your eyes adjust to the dark while you're standing out there before you see it. Another question? Yeah, in front.
If they don't know about the dark skies that are not that far from us, the Dark Sky Park.
Yeah, so Michigan is actually really lucky to have several dark sky parks. I'm going to start with the ones way up north, and we have the Keweenaw International Dark Sky Park all the way up in Upper Peninsula at the Keweenaw Mountain Lodge in Copper Harbor. We also have Headlands International Dark Sky Park, which is a decent drive, but it's totally worth it if you're going near Mackinac City. And then the one down here is called, I'm struggling blank because I'm Headlands, and then there's another one nearby. And it's near Jackson. Yeah, it's near Jackson. The name is escaping me for a moment. Okay, Lake Hudson is the dark sky area. I think there's another one in addition to that, but they're not always open. So, there you go. Yep. Say it again. Port Crescent. Yep, Port Crescent is a dark sky area as well. Yeah, there are actually quite a few, and I've seen articles on it. You can look at a list. I think there's at least 7 different parks in Michigan, so that's a really good place to start. Anyone else have questions? Yeah, over here. And I will say, if you're gonna chase, give yourself at least 3 hours out there if you're really serious about it. Look north, take a test photo on your phone, and really let your eyes adjust to the dark. Sometimes it takes time, and you really have to be seeing the stars so bright before you catch the aurora.
Yeah, I have a couple. So you listed on the screen some upcoming events. Are those listed on your website, or where can we find those so that we remember them?
So the question is, there are some upcoming events listed up here. Where can you find those? You'll find some of them on the Michigan Aurora Chasers link tree. They're also on my website under my events page. So they're listed at kaelinart.com. It's this right here. It's Kaelin art.com. I have events listed there. I always keep it updated with new speaking appearances, and they're coming in fast.
And you said you go with people to chase them. Is that the Chasers Workshop that you're talking about? Or?
Yeah, so the Michigan Aurora Chasers Workshop, we will actually go out with people to chase that night. Now, when we plan something this far in advance, there's no guarantee of aurora. The live, because we can only predict what's happening on the surface of the sun 2 to 3 days in advance when it's headed toward Earth. Anything beyond that 3-day prediction is really based on historical data, and it's not that reliable. So we can't plan anything more than 3 days in advance and know we're going to get aurora, and even then there's some question. But we will hold live chases in the group. We sometimes, if you join the Michigan Aurora Chasers on Facebook, we'll announce, it'll be really short notice. We'll see everything blowing up and we'll say, everyone, tonight, live chase. Here's when and where. Meet us here. One of our group experts will lead you to catch the Northern Lights. You're not gonna get a lot of notice though, because these things happen quick, but we do host them within the group at various times.
Yeah, I'm a member of the group. I've never seen one of those announcements yet.
Okay, we haven't done too many lately. We did 3 to 5 live chases in the first year. I just held one in August, and we did one shortly before that. It's been hard to catch the aurora lately between wildfire smoke and clouds.
Yeah. And where did you get that totally awesome lamp that's showing the northern lights on the wall?
What is that totally awesome lamp? Is the question. I got this as a Christmas gift. It's, what's it called? Aurora lights. I think you can find it online, and I've actually seen some in stores. It's really cool, especially when you turn out the lights. So you can have aurora right at home, even if it's not visible through the clouds. Another question, anyone? Here's some more resources too. These are some websites that will give you some good forecasting and terminology and definitions, as well as some good updates. If you're gonna use an app, we recommend Space Weather Live, but it does have a steep learning curve. You can hit the little info button and it will help you understand what you're looking at. Another one that you have to get online, not in an app store, is the Glendale app. And anything beyond that you can use, but take it with a grain of salt because it's going to be talking about KP the whole time. Was there another question?
Yeah, when you talk about the BZ index, how is that data collected? Is it like with instruments on Earth, or is that through the satellites?
Yeah, how is that data collected when we talk about BZ? and whether it's positive or negative. I think they're using the satellites we have in outer space as well as some of those spacecraft that are orbiting the sun to collect some of that data, and they're developing that technology all the time. So I actually don't know a lot about that. I'm actually not a scientist, but they're observing it from outer space. Some of the K measurements that we talk about are actually being collected from ground-based observations, so they can use magnetometers to detect the K from the ground, but they're also detecting the K with magnetometers that are on spacecraft in outer space as well. So there are both ground observations and space observations. I think with BZ, though, it's probably limited to outer space. Yeah, another question over here, and the mic is coming. Oh, also at the bottom here, there are some paid alert services that you can get. The Space Weather Prediction Center will give you the forecast for free in your email, but I think if you pay like $1 or something a month, they'll actually text you some updates. And then there's a service called Aurora Notifier that's run by someone I know that is really good. You can pay for those updates as well. But live sightings are usually your best bet. And those are free.
Regarding your book, you're selling them. How much are they?
Yeah, so my book, Below the 45th Parallel, is for sale tonight for $15 each. I can take cash or credit, or PayPal, or Venmo, or Cash App. Or Other questions? Yeah, one in the back.
So we saw that the forecast was there in the 3-hour slots. So does it really give any trend in the day hours? Because, I don't think we can see any lights in the day, but I saw that the forecast was throughout the day. So can we kind of monitor the day ones to kind of figure out like what could happen today night?
Are you talking about the ovation model here? Mm-hmm. Yeah, so actually what's happening here is you're looking at the globe from the North Pole down. So this is sort of a slice of the top half of the Earth. And they also have one for the bottom half of the Earth. That would be for the southern lights. This is for the northern lights. So up here in the center is your North Pole. There's this dark line right here where it's showing this is nighttime. And then on the opposite is daytime, where it's a little bit lighter. So that line, this is actually going to be when the sun is up, and then this is going to be sunset, and then beyond that, you're going to have nighttime. Can you watch what's happening during the day as it rotates around to see what's going to happen at night? Yes, you absolutely can. In fact, a lot of us do that. So I'll be, sitting at my desk, taking a lunch break at work at, 12:05 p.m. in Michigan, and I'll pull up my little ovation model and I'll be like, woo, 53.4 gigawatts. I'm gonna look again later tonight and see if that's still happening. Now, in my experience in 11 years of aurora chasing, these things don't tend to be very powerful for more than 24 hours. So if you see it looking good during the day, you have a chance that night, but probably not the next day. A lot of people in our Michigan Aurora Chasers group say, should I go out tonight or will it be better tomorrow night? My advice is do not wait. If you know the aurora are amazing, go outside. You're gonna miss it. So, and they really don't last more than 24 hours to maybe 36 hours sometimes. Sometimes we'll get hit by several impacts of solar activity in a row, and that can cause nights and nights and nights of aurora, but that is extremely uncommon.
One more question. So apart from the aesthetics that we want to look at, such beautiful lights in the dark skies, is there anything that the scientists are looking forward to kind of get from this, energy that we are going to get from the sun? Like, are they looking to harness, or are there anything that kind of, apart from the beautiful view that it gives us?
Yeah, apart from the pretty view that the aurora gives us, is there anything else the scientists are looking for? Actually, yes. I didn't spend a lot of time on this tonight, but the space weather forecasts are not issued for aurora chasers. We're the last people they're thinking about. In fact, the reason that those forecasts and those agencies exist is because this geomagnetic activity has really strong impacts on our power grid. It's caused outages of power in Sweden and Canada. It can cause interference with satellite-based GPS. So if you're out hiking and using a Garmin GPS system or something, your GPS coordinates could be completely wrong. And in fact, it can cause harm to astronauts if they're outside of a spacecraft. It can also cause satellites to come down in a fiery explosion. In fact, SpaceX had an incident, did anyone hear about this? Where they launched 42 SpaceX Starlink satellites into space during a geomagnetic storm, and all 42 of them burn up, came crashing down. So this is extremely powerful, and I see a friend of mine who works for an energy company sitting back there too. These are extremely powerful impacts that have other implications other than Aurora, and that's why they're trying to forecast them, is to actually prepare people who work in our infrastructure and on the power grid to have a backup plan and to protect us in case of power outages and things like that. The good news is there's not really much harm to humans other than the fact that we could go back to the Stone Age and lose all of our cell phones and electricity. But by the time this reaches Earth, the magnetic field and the magnetic shield have protected us from most of the radiation and things like that that come with the solar activity. So for us, it's mostly pretty lights, unless we maybe get a G5 storm equivalent to KP9, like the Carrington event, to send us back to the Stone Ages. That would be the day. That would be really kind of a historic day that would change life for everybody. Another question here in the middle.
I'm one of the Aurora groups I'm in. They keep talking about what in one of the groups I'm in, it says 2024, 2025 will be really high Aurora sightings. Is this true?
Absolutely. So she says it is 2024, 2025 going to be really great Aurora sites, like they say in the groups. Yes, this is what they consider solar maximum, solar max. And according to scientists, they originally thought it was going to happen in 2025, but they have a panel of scientists that discuss this. They reconvened, and they actually think it's going to hit between January to October of 2024, which means solar max is hitting right now to this October. And actually, for those of you here tonight, I have talked with scientists both in my office where I work and in the hobby, who say that some of the most amazing activity and outrageous activity happens the year after solar max, as the sun starts to turn around and head towards solar minimum. So 2025 could also be a really great year. Now, that doesn't mean Aurora is going to happen every night. It just means it could be more powerful, and it will probably be more common. And actually, the other night, we started the new year off with an X5 flare. Unfortunately, it missed Earth. It didn't cause us any aurora, but that was pretty outstanding.
So could you repeat the time frame, the best time to see it?
Yeah, what are the best times to see aurora? Actually, there's some generalizations that I didn't discuss tonight. Aurora, in general, are best 2 hours before and after local magnetic midnight, which in Michigan is about the same as midnight. So 2 hours before midnight and 2 hours after midnight. That's when the nighttime becomes most susceptible to some of these impacts. But it really depends on when those CMEs and different solar activity hit Earth. It could happen at any time. In fact, in the Michigan Aurora Chasers, when we know something is happening and it hits in the afternoon, we'll tell you, get out right after sunset, because we know that this is happening now and it could be visible at any second.
My mom and I were talking about traveling possibly to Iceland or Alaska. My fear is to go out there and not see anything. You go out there for a couple of days or whatever. Obviously no guarantees, but I'm hearing people saying, they're going and they're seeing. Is it just luck, or?
Is it just luck if you're going to Alaska and Iceland to see the Northern Lights? You do have to find clear skies, and when you're out by the oceans, that can be really hard. I know someone who went to Iceland and didn't see it a single night they were there, mostly because of cloud cover. It is a lot of luck, but if you plan, you can look at cloud cover averages for any part of the world throughout the year, and you can try to go at a time that has the best cloud cover averages, like the most clear skies. So planning for that And another thing I didn't mention is that the peak season for aurora happens every year between the fall equinox and the spring equinox, between about September to April every year. That's the peak season of aurora. Now you can see northern lights in the summer if you have dark skies. In Michigan, we get dark skies all year. In Alaska, they don't. Ha ha. But anyway, there is a peak season that falls during the winter months, and some people don't like going out there in the cold, but that might give you your best viewing as well. You might get some of that crisp winter weather where when the snow's down, it stays down and you have some stars above you. So what can I recommend? I don't know. I would look at cloud cover averages. I would think about the peak season from September to April. And then a lot of it is luck. To be honest, when I went to Alaska, we saw the aurora 7 out of 8 nights. And I, as an avid aurora chaser, saw them from the plane both on the way in and on the way out. But we chased. One night we drove over 5 hours between 11 p.m. and what would that be? 4 a.m. And we finally found a hole in the clouds at about 3:30, 4 a.m. and saw the aurora. So the more effort you put into it, the better your chances. But it is luck sometimes. And even seeing them on the plane, it's the funniest thing. You know, I was so excited. I've never been to Alaska until last year. and I looked at the flight attendant. I knew my other aurora chasing friends were on the plane, and I said, if there's northern lights, will you let us know? And she said, oh yeah, we always do that. And I was so excited, and I was waiting, and we're halfway through the flight, and I haven't heard anything. I'm like, man, I'm going to Alaska. They gotta be out there somewhere. Like, you know, we have like, in-flight internet now, so I'm refreshing my website with my Ovation model, and it looks good. And what do you mean there's no aurora? So I look out the window, and I focus my eyes, and I try to block out all the light from the cabin in the plane. And then I couldn't really see anything, so then I pushed my camera up against the window to take a test shot on night mode, and it was really shaky on a 30-second exposure, but I turned it. So the thing is, you do have to look for them. I caught the aurora from the plane before they did, and they fly to Alaska all the time. So you do have to try, and it is a bit of luck, but you can use some of those tips to try to help you.
So when you have a chance, how long does it last? Like, is it like 30 seconds, 2 minutes, 10 minutes? What is the chance?
How long does the aurora last when you have a chance? It really depends. Let's see, maybe I can take you back to some photos here. I did a live chase with the group in the Upper Peninsula of Michigan. And it doesn't really matter that I was up there, although it does increase your chances the farther north you are. This is the photo here. The aurora during a really strong geomagnetic storm came out right after sunset. In fact, I think one of the photographers caught both sunset and aurora in the same photo, which is possible. And then they danced all night until 1 a.m., 2 a.m. It got to 3 a.m. They were still dancing. There were still all these colors. This was right over Lake Superior. That's me by this really large tree. It danced all night long. At 3 a.m., I said, man, friends, I'm sorry. I got to go back to the hotel and check on my dog. And one of my friends turned to me and said, are you crazy? It's still going on. And I said, no, I'm serious. I'm tired. I'm going to go back. So I went back to my hotel, but what she didn't know is I had a private balcony looking north over Lake Superior. So I checked on my dog, you know, I got a warm beverage, and then I looked outside, and the brightest part of the show happened at like 4 a.m. in the morning with aurora just like streaming straight toward me in pure neon green. And so all night long, but that was a strong display. Now to counter that story, there was an event, not last year, since it's January, but the year before, in 2021. Yeah, so 2021, I think it was Labor Day. I was looking at all these sightings in the Michigan Aurora Chasers. Everyone was catching this beautiful aurora, and they caught Steve and everything. And I thought, wow, this is so incredible. It must have been the best show of the year for everyone who was up north. Unlike me, I live down here near you guys. And I was just wondering, like, how much did I miss? So I'm looking at the timestamps on all the live sightings. What time was this photo taken? What time was that photo taken? And I talked to a friend of mine who was up at his cabin, and I've been on the phone all night with him talking, go outside, go outside. You have a chance to see it. And he caught the Northern Lights for the first time, but only for 15 minutes. I looked up the timestamps from that night, and everything I saw was taken in a 15-minute period. And everyone I talked to about the Labor Day show said, yeah, a little bit of aurora was out, but it wasn't really visible to the eye for most of the night. But there were these 15 minutes that were just mind-blowing. So think about you're aurora chasing, or you're up at the cabin or whatever, and you go outside to try to see it, and you're out there, what, I don't know, 10, 20 minutes, 30 minutes by the fire. You turn around, oh, I need a coffee, go inside, la la. Come back out 15 minutes later, you had time to give a treat to the dog or whatever. And in that 15-minute break, maybe you missed it. So like, it does help to chase in a group, and you really never know. It can last 5 minutes, 10 minutes, 15 minutes. It can last all night. Often it will last for about a half hour to an hour. Then there will be a lull, then another half hour, then a lull and a half hour. So it really varies. But it's just crazy, the stories. You'd be like, I can't believe you got that shot. No one could see it that night. Well, maybe you just weren't looking up in that 5-minute span. Like, who knows? Another question over here, and I could repeat it too.
Real quickly, could you explain what the different colors mean?
Yeah, can I explain what the different colors mean? So actually, and we breezed right through this during my talk. That solar wind contains particles and energized, energized electrons that are coming charging toward the Earth. And when they actually do enter Earth's atmosphere, they intersect with molecules of air. So these charged particles, it's a long process actually, where they get charged up in the magnetic field and enter our atmosphere. Then they collide with oxygen and nitrogen and helium. And depending on what air molecules are above us, those emit light. So we most often see the aurora in green, or in Michigan in red, because green is emitted from oxygen molecules at high altitudes. And red is emitted from oxygen molecules at low altitudes. Helium emits sort of a pink and purple, if I'm not mistaken, and I sometimes get these backwards. And nitrogen emits a blue or a purple. So all the different air molecules emit different types of light. And actually, sometimes when you see pictures of the Aurora Australis or the Aurora Borealis in the north and compare them to the Aurora Australis in the south, their colors are a little bit different. I think they must have a different composition in their air down there. So it's actually really fascinating. I still want to see a blue aurora. I have not seen a blue aurora. That's the dream. All right. Well, I'm happy to answer more questions at the end of the program, but thank you all for coming. I'll be around. Good luck on the Aurora Chasing Trail.
Thank you for watching our presentation. In order to discover upcoming events at the library, please visit our website, westlandlibrary.org, and click on our events calendar for a full list of everything that we have. You can also visit our Facebook page at Westland Library for daily updates. Thank you for watching, and we hope to see you soon.